Hello everybody, welcome back to my basement. Today we are here to do a demonstration of how to get started using R and RStudio software. So where I am in terms of our materials is on page 10 of the handout that is posted on 2/7 for 6243, Introduction to the University of Iowa's Virtual Desktop. So you should have completed all of the steps up to this point following the previous video. You have your VPN running if you want to use the virtual desktop. If you want to use R as installed on your machine, I am assuming that you have already done so. So you would need to install R, the program, first, and then RStudio, the graphical interface, second. If you haven't done that yet, here are the links to where you can find those things, and you can hit pause and go ahead and do that, but I've done so. So I am connected to the virtual desktop at this point. I have pulled up RStudio inside it. This is what it looks like on my computer, and this is what it looks like on the virtual desktop. So as you can see, they look very much the same. The only difference is that I have found that running RStudio on the virtual desktop takes a lot longer. So given that the entire reason people adopt R is because it's free and it can be installed on any type of machine, Windows, Mac, Linux, what have you, we're not going to use the virtual desktop version right now. We're just going to use my desktop version, and you can follow along with your own. All right, so let me get this window maximized. So there are a bunch of different windows in here. I don't actually use all of them, but I will show you the ones that we do use. So the first step is to open up the example program that we'll be working from, which is example 1. So I am going to go here and go to Open File, and then go and find where that file is inside example 1. So here's example 1 rsyntax.r. We'll open that, and it shows up here. So right when it opens, it moved the windows down here so that we have console, terminal, and jobs down here, and the area in which you're typing is up here. So I'm going to move these windows around. By the way, under, I think it's View, or under, so there's options up here. I can't remember where it is. You can move the windows around, but this is how it installs by default, so I thought I'd keep it this way for right now. One thing that you may see that I'm not seeing is a yellow message right here that's warning you that certain packages that are referred to are not yet installed. You don't need to worry about that. You can say go ahead and install them if you want to, but every example that I'm going to give you should have code in it to install the packages that you need. So that's the first thing that makes R different than SAS or Stata or SPSS, is that oftentimes people write their own custom routines to do basic things that they want to do that are not found in base R. And so you can download and use the software that they've written as part of R, and those are known as packages. So for instance, I have code right here starting on line 16 that is going to check to see if 2 of the packages that I need for this example are downloaded and install them if not. So we have if this package is not there, then install it and then load it. So the good news is that each time that you want to use a new package, you only need to install it once, but subsequently, in order to bring the package into memory so that it can be used, you have to load it, as it's called. So this library function essentially activates the package so that it can be used in your working session. So that's what that little message up here would have indicated. So starting at the top here, this sign right here, either a pound sign if you're old like me, or a hashtag if you're not, is a way of indicating comments. So comments more generally are notes to yourself. They are pieces of text that the program will ignore. And this is a very important thing to get used to doing, because this is your trail of breadcrumbs once you figure out how to do something, to leave yourself a note as to how it works or why you did so. So I have notes here to start with. First, what are we looking at? Example 1 is what I've titled this. I am setting display options, so you can control how wide the text prints to these windows before it wraps based on the size of the screen that you're working with. And likewise, you can control the number of significant digits that are printed to some extent. So certain packages will not abide by this command. They will override it with their own specifications. But as a safety mechanism, I try to do that at the top of my program so that enough precision is displayed for whatever answers you're looking for. So this just controls the display of the output that will be shown down here in this window once we actually do something. So I have notes about the syntax structure right here. Each R command is contained in parentheses. So R is nothing but a series of functions that are called. And the use of RStudio that we're in right here helps to make sure that your parentheses are specified correctly. So it warns you if you have an open one that doesn't have a corresponding closed parentheses, for example. There are a few different colors in this language. Green is for comments, blue is for recognized commands, and black is for things that you would potentially change, such as names of commands, variables, data sets, and so forth. Below, there is a common argument to each of the functions that is X. That refers to the name of the data set or the variable that is going to be used. So I just have a general note about that. In terms of executing this code, so to make the code go, so to speak, you can highlight the text that you want, and you can either hit run, or a keyboard shortcut is Control plus Enter. So up to this point, the only thing that would actually happen is the change of the display. So I'll go ahead and hit that right here. So you'll see that down here, it printed back in blue font what I asked it to do. So this window down here that's labeled console is both a log and an output directory, meaning it will echo back any commands that you have specified. It will give you any error messages that pertain to those commands, and if the commands run successfully and you have requested some kind of additional printed output, it will show up down here. So everything gets dumped to this window. It fills up quickly. Fortunately, you can clear it. So this little broom icon here clears the console. So in between commands, you might want to clear it so that you have a fresh page to start from. Makes it easier to find what you're looking for. So I don't need to run these comments, but just to show you what would happen if I do, nothing. So it's just echoing back what I wrote. I do need to run these two things. So what I am doing is checking to make sure that I have these packages installed. If I haven't installed them already, these commands will install them for me. And if I do have them installed already, meaning I've used them before in this installation of R, then it will simply load the packages that I need so that I can use them right now. So I will hit run, and you'll see various text here. So it's loading the packages. This may take a little bit. So if it seems like it's taking a while, some packages have a lot of other packages that they're dependent on, and they install all of them. So it can take up to a few minutes for packages to be installed and loaded. When it's all done, though, you should see this blue text and a cursor that's waiting for you to continue. In my programs, I use this type of block comment function to divide the program into sections. So this is a header that specifies that everything that follows pertains to data import and manipulation. For instance, here's another one that starts the later section on univariate statistics. So this is just my way of helping you navigate the file. Here next is the most important part. How do we tell R where to find the files that we need? This can be very tricky across different operating systems to specify correctly. So the command setwd stands for set working directory. And this is where my files are stored. So I use Dropbox off of my C drive. Note that the slashes are backwards relative to what they would look like in Windows. Now, how did I ever figure that out? I want to show you an easy way within R to figure out what the correct path would be so that you can replace it with your own path in here. So I'm going to go over to the Files tab on the right-hand side, which is currently within my C drive. So this will be one of the few things that we actually do using drop-down menus in Windows. I'm going to go to Dropbox. I'm going to find the folder for this class. And I'm going to find the subfolder for example 1. And here are all of the files that we'll be working with in terms of data, syntax, and output. Under this More option right here, the little blue wheel looking thing, there is an option that says Set as Working Directory. So I'm going to go ahead and click that with my mouse and watch what happens. The code that it wrote for me through those mouse clicks has been generated in the output window. So now you know what you should have written to get to that place. And that is how I figured out exactly what this path needed to look like. In theory, you don't need to fill in this command and execute it because you've already done so. However, in practice, it is not good to rely on a series of mouse clicks in order to get to the right spot for your data. It is much better to have it hard-coded, included as part of your program. That way it is unambiguous where your files came from. So I would highly encourage you to get the path that you just found as to where your files are and put it in here so that you have it the next time that you want to run this program and you get used to doing it every time you want to work with data. So I will go ahead and run this just to show you there's nothing new. It's ready to go. And the next step then is to import the data. So the commands to import data into R will look different based on what kind of data set you're trying to import. And in this case, because I am using an Excel data set, I picked Excel because it is a file type that can be opened regardless of whether you actually have any of these programs on your computer. So you can open it outside of R, SAS, data, what have you. I used a package called Read Excel to be able to do this. So what is happening on lines 33 and 34 here, you do not need to change these unless you somehow renamed the data set. If you left it as downloaded inside the folder, then this will be fine. And I should mention, by the way, let me back out of this 1 second. I am using the folder that has been extracted. So if you downloaded this folder as a .zip compressed folder, you will need to have extracted it already into a folder that has files that you can access. So I have done so already. You will have needed to do so before you can actually work with these files. Anyway, lines 33 and 34. So what we are doing is importing an Excel data set. So the path is a bad name. It actually means file name. This is what the file is called. Note that it is in quotes, which means it needs to be case and space sensitive. You need to get it exactly right. It's gss_example.xlsx, so with the extension. Excel workbooks can have multiple sheets, so to clarify which sheet you want to import in particular, you can add a sheet command. The sheet is called GSS example in this case. So taking this file, this sheet out of this Excel workbook, it is going to read it and save it as an R data set that is called example 1. So in R, you can have multiple data sets open to be used at the same time. So it is imperative to name it so that you know which one you're referring to. So throughout this program, I am referring to example 1 as the file to be used. That means that if you decided on a different name, you would have to change it throughout the program where it refers to example 1. So for present purposes, I would just leave this alone. The set working directory should be the only thing that you need to change to make this example code work exactly as it's written. So I am going to run these 2 lines right here just to show you what happens. So blue text, that is good. Example 1 shows up now under here of data, and it tells me that I have 734 options of 10 variables. So I can double click on it and I get my data set here. One issue with data in R is that there are actually multiple different kinds of data sets. There's tables, there are things called tibbles, which I honestly don't know what the hell that is, and I don't think I need to know. But critically, in order to do analyses with most of the packages, the data have to be stored as what is called a data frame. A data frame is a set of rows and columns that all have the same dimensions so that we can use it as a standard data set. So I've gotten in the habit of including this additional line just in case the way that the data were imported was one of the other many kinds. So I am converting example 1 to a data frame, as we will need to use down below. Oops, Control Z for undo on that one. So I'll go ahead and hit run. And now I know that it is able to be used. And at any point, if you want to look at it, you can double click on it and see what it looks like. I will note that all of these variables are numeric variables. They're right aligned. If they were left aligned in most software packages, and I think in R, that would mean that they were stored as text instead. So that's one way that you can tell just by looking at it what kind of data that you have. You can also click on this data and it will tell you more specifically what format each of the variables is in. All right. So next step. When I demonstrated all of the other packages, SAS and Stata in this class, I executed code that added what is known as variable labels and value labels. So variable labels are text strings that get attached to a variable column that provide more detailed information as to what the variable represents. They are not necessary, but they are good practice in working with data so that anyone else who looks at this data set will have a better idea as to what the variable represents, and it's stored with the data, which is more convenient than referring to a separate code book. However, when I attempted to find analogous ways to do this in R, I quickly realized that a lot of packages will not accept data that have labels attached to them. So rather than try to fight my way through it, I have accepted the reality that the easiest way to set up variable labels is not to attach them to the data, just to have them in the file for reference. So that's why these labels are all comments, because that's what I'm doing. I'm not attaching them to the data like I would in SAS or SPSS or Stata. I am simply putting them in the file for reference. So the 3 variables that we're going to be working with in this example file are marital status, which is a 5-category nominal variable, happiness self-report rating, which is a 5-category ordinal variable, and income, which is a continue-ish quantitative variable. So those labels are here just for your own reference. What we need to know in order to be able to do anything with these variables, though, is what their name is. And that's the part that is right here. So I always have the name and then the label after the equal sign so that you know what the columns are named without having to explicitly refer to them. You can also do so by looking at this list over here in the environment window. Likewise, I quickly discovered that any routines I found to add value labels, so verbal labels that correspond to categorical variable numbers, is not really a thing in R either. So Jonathan helped me make a workaround to this, which is to create new variables that are text string variables instead. So that's what I'm going to do to be able to create labeled versions of the marital 5-category variable and a labeled version of the happy variable. So first thing that I'm doing is making a list of what I want the value labels to be for each of these variables. So I'm creating what's known as an object. So this is just a saved piece of information that R has access to that describes the labeling convention that I want to use. So C stands for concatenate, means stack together. This list of what I want the labels to say. So 1, I want to be married, 2, I want to be widowed, and so forth. I am in the habit of always including the number that corresponds to the label inside the label itself. I do that because some packages, if you only provide verbal labels, when they print output, will reorder the labels alphabetically as opposed to the numeric order that you started with for the original variable. So to avoid that potential confusion, I always include the number that represents the category as part of the label that I'm adding. So the same thing then, I'm making a separate labeling convention stored as an object called happy labels, with the labels for the self-reported happiness response options. So if I run just that little snippet of code, now my window is filling up, so I'm going to drag this down so we can see. So over here in environment, it's giving you a list of all of the different objects that you have stored. So we have an example 1 data set, and then we have these labeling conventions that we've just created. The next step then is to create new text or string variables out of the numeric variables so that we can have these labeled values attached to them. So to make a new variable in R, you have to tell it the data set the variable is going to be contained in, as well as the name of the new column you are to create. So this command right here on line 52, example 1 is the name of the data set. The $sign is a separator that then denotes the name of the variable to be created. So a new column is going to be created in the data set. What it is going to be created out of is this labeling convention as applied to the original marital variable inside the example 1 data set. So I'm essentially copying the information that's in marital into a new column that's going to be called marital labeled, and the new column is going to be a text variable that has those labeling conventions applied to the values. I'm doing the same thing to create a new variable called happy labeled out of the labeling convention happy labels described up here, and it's made out of the original column for happy. So if I execute those 2 lines, I don't have any new objects because what I have done is create new columns in example 1. So if I double click on that, you'll see now that I have 2 new columns. So marital is the original variable. This person had a 5. So on the new variable, they have a 5 labeled never. So these are string variables. Generally speaking, you don't want to work with strings if you can avoid it, but in this case, I can control the consistency of the strings because they're being converted from numbers directly. So these are the 2 new columns that I just created. I will then ask for descriptive output for these new columns. That way the labels get shown as part of the output. Ta-da! So variable labels, value labels. So just to recap what we've done so far. We have controlled options for the displayed output. We have checked to see if the packages that we've needed to use have been installed, installed them if not, and loaded them. And the most important thing, the thing you cannot forget is right here. You need to change the directory that you are using as your working directory to wherever you have stored the example 1 files in an extracted format so that you can edit them directly. After that, we have imported the Excel dataset, and we have made sure that the dataset is in a data frame format as needed to do anything with in this example. Finally, we have created 2 new variables that have labels for their categories in addition to the numbers. Moving on. So now we can get to the part that you will need to be able to understand in order to do homework 1, which is just generating univariate statistics. So in lecture 1, I showed snippets of code and the corresponding output that that code created. Now I want to show you how to actually get that output yourself. So first up, we had categorical predictors. So for instance, if I want to know how many people were in each possible category of marital, I am going to use the labeled version, and I am going to first create a title for my output. So the print command, parentheses, and then words that you type here inside the quotes. What that's going to do is echo that text to the output. So I do this so that my code is as similar to the code I'm showing in SAS and Stata as possible. But in general, it's helpful to add either a comment or a print option like this that describes what you're doing and potentially why. It helps to make your output far more readable than if you just have a series of numbers being spit out and you're not sure what they refer to. So this is like a trail of breadcrumbs that you're leaving yourself in your output window so that you know what you're reading. So these are words that you can choose whatever you want to write in here, as many or as few as you want. My convention is I've always have the package that I'm using because my handouts will have multiple programs of syntax at the same time, and then what I'm doing and for what variable. So I'm going to be asking for a frequency table for the categorical variable marital label. The command that I'm using for that is table x equals the two-part name, the name of the data set, example 1, a $sign, and then the name of the specific variable column within example 1. So in R, you have to attach these two together. There may be workarounds in which you don't have to specify the data set, where you can have it default to a certain data set, but that's generally bad practice because it's hard to tell what it's defaulting to if you don't run the code in the same order. So for ultimate transparency, I am going to be consistent in referring to the name of the data set and the name of the columns that I'm operating on. So I want to get a table that summarizes the number of people in each category for the column marital labeled within the example 1 data set. And then this part right here says, hey, if anybody's missing information on this variable, tell me how many people are missing. So this is the analog to the option missing as it is written in SAS and Stata. So let's run this, see what we get. Ta-da! So this is all you would get here other than the echo of the command. That's why I have this print option here, so that I have a title as to what I'm actually looking at. So it's telling me I have 337 people who said they were married, 17 that were widowed, and so forth. So in R, this only gives me frequencies, whereas analogous procedures in SAS and Stata give me frequencies and percentages. So I'd like to get the corresponding information about percentages. The way that I can do so in R is to embed the function that I just used up above. So the interior of these parentheses is literally the same as 63 up here. I'm embedding this table function inside another function that is called prop table, which converts your table into proportions. So note the placement of the parentheses here. So here's an open parenthesis that opens the function prop table. The corresponding closed parenthesis is right here. Then for the interior of the function, this is the open parenthesis within the table function, and this is the closed parenthesis. So this is an easy thing to screw up. Fortunately, R tries to help you, RStudio I should say, if you screw it up. So let's say that I'm writing this and I forget this one. See, now it's angry. I get these little red X's because it doesn't understand what I'm doing, and it tries to tell you where it thinks you screwed up. So there's a little red underline right here saying, hey, there's only one closed parenthesis, and so this is going to be wrong, and this is going to be wrong, and this is going to be wrong. See, it's wrong all the way down. If you just saw all these X's, you'd think, oh my goodness, I've screwed up my whole program. But no, it's reading it exactly the way that you've written it, where the close and open parentheses are now off through the rest of the program. Once I fix it like that, and then I move my cursor down, now it's reading everything correctly again. So let it help you. Make sure that you have your parentheses open and close in the right places and in the right numbers, because that can be a very tricky thing to satisfy. So now that I have this correct, I'm going to run those pieces of code, and now you'll see that I have converted these frequencies into proportions of a total. So this is the way that you would read this is 0.46 out of 1 are married people. This corresponds to 46% as it would be displayed in Stata or SAS. All right, I'm going to clear the window here. Next up, pictures. In preparation for that, I'm going to move this thing up here, and you'll see why in just a moment. So the next thing I want to demonstrate, not something you need to do for homework one, but something you might want to do in your life, is to do a bar chart. Make sure I'm still recording. Paranoid about having forgotten that. So I'm making a frequency plot, bar chart, bar plot, whatever you want to call it. The arguments to this bar plot function, height is, okay, what are you plotting? And again, I'm using, what it's plotting is this table function output. So I am plotting the frequencies in this case. So this continues the function. So the comma separates arguments within the function. Height corresponds to that. Here's another argument that corresponds to the label for the y-axis that I want. So these are words that you would change as needed. This corresponds to the label for the x-axis. And so I have a comment here as to what I'm doing. So comments can go on specific lines at the end. They can go before a command. Comments can be used pretty much wherever. And if it doesn't turn green, then you know that it's in the wrong place. So I'm going to make myself a little picture. And here it is. So this window set here changed from files to plots because I made a plot. And look at the label for 4 was missing because the plot was squished. So the resolution that it gives you depends on how much room you have currently allocated to this window, which is kind of crazy. But yeah, so if I squish it, the labels disappear. Not ideal, but it is what it is. On that note, the other windows over here that you might need to refer to, packages, has a list of all the packages I think that you currently have installed. Viewer, I'm honestly not sure what it does because I've never used it, but I think it has something to do with R Markdown. And the help menu. So this is something that's really important that I did not realize until recently. My previous strategy, if I needed help using something in R, is to go to the internet and type it into the Google. That, turns out, is not a great strategy because these packages may change over time, and you may find yourself looking at a web page for a package that is out of date relative to the current version that is installed in your software. So to prevent that, get in the habit of looking for help within this help window because this help window is tied to the particular version of the packages and software that you have installed. So for instance, if I wanted to know more about bar plot, now it tells me what all of the potential arguments are, as well as which ones are defaults to whatever. And so it gives you more information about what each of these things is potentially doing. If you want to find a particular command within this page, that's what the second search bar is for. So if I wanted to find out more about what YLab meant, for instance, then it works as a traditional search where it highlights all the places on the page where that command is referenced. So if you need help, go over here for the package or function, and then within the page, you can search for more particulars. Anywho, back over to the code. We're on line 74. So this plot that I just made has frequencies. If I want something that looks more like percentages, then I have to trick bar plot. So the way that I decided to do that is to embed this prop table function inside height instead. So I've got all of that. Let's see. Make sure I've got all my parentheses. Yep, 1, 2, 1, 2. And then times 100 so that it's a percentage rather than a proportion. So I'm tricking it by saying find the height as a proportion and then multiply the height by 100. And I'm keeping the same labels except I'm changing this to percentage. And then this is what it looks like. Okay, so now I'm at percentages. So you'll notice that this picture over here is not in the same place as your output. If you are not using R Markdown or anything that sort of weaves everything together and you want to save the pictures that you've made, here's a command that allows you to do so. So the structure of this next little section here, starting on lines 78 through 82, you are opening an external file to write the picture to, you're making the picture, and then you're closing the external file. So PNG is the format that we're going to make for this image file. So this first command on line 79 is opening the file and giving it a name. So I'm going to call this rMaritalPercentagePlot.png. then I embed the previous command inside it. So this is the same. And then dev.off closes the file. And I honestly don't know what it means. I just know that I found it and it works. So if I were to run this, I would end up with the same file that I've already made here. So that is where this came from, our marital percentage plot. All right, moving on. Line 84. How about descriptive statistics for quantitative variables? So things like mean, variance, and so forth. So a different command for that requires a separate package that I had downloaded. So there is a package that is, I think, very popular. It's called Psych. I believe it's written by Bill Revell at Northwestern University. He's in the psych department there, as one might guess. And so he wrote a package that contains a bunch of routines that provides output that you would want to have in the context of social sciences like psychology. So one of the things that he has here is a describe function, which is a way to summarize many aspects of a quantitative variable at the same time. So in this case, I have a print label saying I'm asking for descriptive statistics for the quantitative variable that's income. And then I have comments here that explain what each piece of the function is doing. So if we just go with the interior part right here, so describe is the command. The arguments to the command x equals, that's going to be the name of the data set with a separator $, and then the name of the variable that I want. Quant stands for quantiles, or percentiles as they're sometimes known, and I'm asking for the 25th, 50th, and 75th for correspondence with my other examples. You can ask for whichever ones you want. Note that those are embedded in their own little list. So C again is concatenate, so it's a list of the ones that I want rather than just a single value that would go after this equal sign. So anytime you want to have equal more than one thing, you have to set it as part of a list rather than listing them separately. IQR equals true means yes please, I'd like the interquartile range to be printed. So this much is describe. I believe by default it only prints maybe 1 or 2 digits after the decimal. If you want more than that, then the way to do that is to embed that describe inside a function. So what am I printing? This result, comma, to what level of precision? 4 digits. So if I highlight those two things and hit run, here is the result that I get. So n, mean, standard deviation, etc., etc. The one thing that's not on this list is variance. So as we discussed in class, the reason is because it is redundant with standard deviation. Standard deviation squared is variance. Variance's square root is standard deviation. So I could get my calculator out and square that number, and then I'd have variance, which is one of the things that I'll ask you for in your first assignment, for example. Rather than doing that, though, because this number is stored with more precision than what it's being displayed, I want to make sure that the variance that is being calculated is as precise as possible. So I have a separate command written to do that. The command is part of base R. It's var for variance. What would you like the variance of? X equals the column income within the example 1 data set. So I'll hit that, and that's the 13.7916 squared is this. So now we have enough level of precision to make sure that it would be counted as correct in the homework system. Likewise, if all you want are just 1 or 2 particular summary statistics, you can ask for them separately, such as the mean, such as the standard deviation. So this is also highlighting the use of a semicolon. By default, R assumes that your command is done when you hit a close parenthesis, and it will stop reading the rest of the line. If you want to change that and have more than one command on the same line, you can separate them with the semicolon. So I will do that, hit run, and that's the mean, and that's the or standard deviation rather. So it's telling you the same thing that's up here, it's just on its own command. Next up, pictures. So again, no pictures required on homework, but pictures may be useful in your life. I'm going to move this thing over in preparation for my new picture. Hist is a command that generates histograms for quantitative variables. So it's like a bar chart, except that it's numbers that are rounded into convenient bins so that you can get a sense of the relative distances between them. So it doesn't plot each exact numeric value, it plots ranges of them. So here I am going to ask it to make a histogram for the income variable. Frequency equals false means I'd like percentage instead of frequency, essentially. It's something called density in R, which I haven't dug into the details of, but it conveys the same thing as percentage. Breaks equals 15 is how many bins I wanted. So I had to work backwards to figure out if I go from 0 to 70 in increments of 5, then that creates 15 bins. And then again, the labels here for the axis. So I'll go ahead and run that piece right here. And we end up with this plot as shown in lecture 1. If I wanted to save this plot to a permanent file, here's that 3-step process again. Open a permanent file using the PNG command. The file is to be called r-income-histogram-plot.png. Make the plot, so this interior part is the same as up here, and then close the external file. And that created this file right here that was already part of your download packet. And then here's one more example of how we might make a picture, a bar plot for an ordinal variable. So that's it. That's all the commands that you would need to be able to do basic descriptive statistics and to do your homework. So this window here, I've been clearing periodically. Everything's being dumped to it. If you would like to save your results so that you can work on your homework later outside of R, you can do so. It's not strictly necessary, because if you have this window that we've been typing in, so note that it needs to be saved, because there's a star after the file name indicating it hasn't been saved yet. To save it, you don't have to do anything special. You can just hit Control S or go up to the File menu and hit Save, just like any other program. And if you have this file that we've been typing in, and you have the original Excel dataset, you do not need to save the R dataset, you don't need to save the output, you don't need to save anything, because you can reopen this code, run all the lines again, and you'll get right back to where we were. But if you want to, I have included code down here to demonstrate how one would do that. So this requires a package I found called Teaching Demos, not a coincidence. And one of the things that it allows is to create just a plain text file that basically dumps this information in it and saves it to an external place. So I know that R Markdown is a way to create documents that look a lot nicer, but I'm just working with something very simple and easy to edit here rather than an HTML file or a PDF file. So I created then, this is what it's doing, is opening a file that's example1 R output. So this is how I made this file right here, is through this command. So if you load the library and then you run this piece right here, and I have a note, code to generate output to be saved goes here. So this is where, for instance, you would embed, let's find something like this. For instance, if you wanted to just save this part, you'd put it here. And then, so this is open the file, do the stuff that you want to have saved in that file, and then close the file. And then the end result of that process will be a text file in your working directory with the name that you've specified. And so that will just have everything dumped to it that has been in this window. It will not have the pictures that you made, which is why I have separate commands for saving those to their own separate files. So that's it. I think that is everything that I wanted to talk about. For the sake of example 1, one last thing is what you'll be expected to do for your first homework. So every homework that I give you this semester is going to have with it your own data set and accompanying starter syntax files in all 3 of the programs. So for instance, this file will be available when homework 1 is available. This is starter code using R that will help you import your homework 1 data set and add all of the labels and formatting things that you need. So when you go to the homework system to download your assignment data, you'll also have this. So what you would do with this information then, first off, is copy it all. So Control A, Control C, and then over here you're going to make a new file, a new R script. So now you have a blank window right next to the other one. So, I just shut it instead. Let me get that back. So I'm going to paste, that's the thing that I meant to have. I am going to save that. So I'm going to save it in the same place, and we'll call it something like homework 1 syntax. How about that? And then I am going to open the one that I had before. So fortunately it remembers recent files. Yeah, let's go with that one. Yep, there we are. Okay, so here's my homework 1. And right away it's already mad at me about something. I don't know what. It's very interesting. I am troubleshooting in real time. Oh, I know what it is. This is a copy-paste error of myself. It is mad because this is not a comment in R. This is a comment in Stata. So I pasted in the comment when I made the starter syntax and forgot to change it. So this is another example of how RStudio helps you troubleshoot your own code. So I'm going to change that to a comment, and now it's okay with me. All right. So this is an example of a homework 1 starter file. The top of it will have whatever libraries are used. So these are the same 3 libraries as used in example 1. And then the part that you have to change is right here. So you're going to set your working directory to wherever you downloaded your homework data to. So that's the exact same process where you can go over here, navigate to the place, and then set working directory, and then copy the path up here. One more thing that you'll have to change to do homework though is the name of the file. So when I do homework to test it out, my ID number is 111111 like this. You will need to change it to yours because the way that your file will be downloaded is with your ID number attached. So once you update this file reference with your own ID number, and then once you update the place where you saved your homework data to, then all you have to do is run the rest of it. So in this homework, for instance, I've already made labeled versions of the variables. I've included all of these variables as comments so that you would have the labels. And then I've also helped you get started with an output file if you want to do that. So I have a note that don't run this until you're all the way done. This piece, you can get all of the code that you want working in here. And then when you're ready to save, you would run the whole piece, open, code, shut. So what do I expect you to do before your code goes here? I expect you to go over to the corresponding example for the homework. So homework 1 corresponds to example 1. Homework 2 will correspond to example 2, and so forth. Find an example of what I'm asking you to do in the homework, such as if I ask you about frequencies, then you can think to yourself, all right, table will give me frequencies. I'm going to copy this instance out of the example file. I'm going to port it over into my homework syntax and then figure out what I need to change. So for instance, if the name of the data set that's being created in homework 1 is this, I'm going to highlight that and copy it. That means that in referring to my example, I need to change it from example 1 to homework 1. Likewise, if the question we're asking about frequencies of, say, gender ID as one of my variables, so I have all the names and labels up here for easy reference, I would copy that and I would change it to this right here. So I'm replacing marital with gender ID labeled because I made gender ID labeled up here for you. And so then you would execute this code and it would apply to your homework 1 data specifically. And you would repeat the process for all of the other questions. Start over here with example 1, find the command that does what you're interested in doing to answer the question, paste it over here, and change the names of the variables and any other specifications that is needed. And that should be it. When you're all the way done, make sure you save your work, save this file that you're typing into, and then optionally you can save all of the output if you want to as well. The homework system is set up so that you do not have to finish it all in one setting. You can save the work that you've done thus far, close it down, and whenever you come back to it, the work that you have done already will still be there. So you don't have to feel pressured to get everything done in one fell swoop. All right, I think that's everything that I wanted to say about that. Please let me know if you have any questions. And as the kids say, smash that like button and hit subscribe. But what do I care? I'm not making any money off of this beyond just my regular paycheck for doing my job. So anyway, thanks for watching. Hope to see you soon.